Hi everybody, in this video we're going to solve absolute value inequalities. So absolute values but with less than and greater than signs. So here there's two different styles and actually two different ways that we solve. So if we have a less than sign or a less than or equal to sign, we do one way. And if we have a greater than or a greater than or equal to sign, we do it the other way. So I'm going to split this video. We'll do one video, but we'll kind of split it into each half. So I'm going to start with the less than examples first, and then I'll show you what to do in the greater than examples. So if you have the absolute value less than a number, and again, here your absolute value is isolated, so you're still getting it alone first. And then your other side is, again, typically positive in this case. If it was 0, then you wouldn't have two sides, you just have the 1 instead. But again, it shouldn't, when it's negative, then different things happen, right? So typically it's going to be positive. So when you have a less than sign, the way that we split this into two pieces is we actually create an and inequality. So remember, this is a style of and compound inequality. It's one of the sandwich ones that I like to talk about. So the right side stays A, and then you put the negative on the left side. So for example, if I have something like this, absolute value of x is less than or equal to 3. The absolute value is already by itself. The right side is positive, so it's going to work as normal. And what happens is this becomes x is less than or equal to 3 on the right. So the right side stays the same. And then you're just going to kind of mirror that and do the negative 3 on the left. And both symbols here are going in the same direction, less than or equal to. And then, of course, you can draw your solution set. So we're going from -3 to 3 here. So you're shading in between those two pieces. And you would use brackets in this case, because we have the equal signs there. And in interval notation, we're going from -3 to 3. If you, as a side note here, if you're struggling on solving these inequalities, there is another video on compound inequalities. So if you skip that video or maybe you've forgotten the information there, I do highly recommend you go back and watch that first before this one. I'm not reviewing the solving techniques for that piece because we've already seen it. So again, if you need to review that, go back and look at inequalities again, particularly compound inequalities. And that's the strategy that we're using here. Again, for this next example, you can see that your absolute value is by itself. That right side is positive, and I have a less than symbol. So I'm going to write it like a sandwich. So the M-6 is going to stay with the less than 2, and then I'm just going to mirror that over here, but make it a negative. And then these sandwich ones, remember, we solve inside to outside. So I'm going to go ahead and add 6 on all sides. I have an 8 on the right and a 4 on the left. So if I am graphing this, so let's see, 3, 4, 5, 6, 7, 8, 9. Again, I'm shading right in between those values. And there's no equal sign, so I would be using parentheses there. And the interval notation goes from 4 to 8, again, matching those symbols. Couple more with less thans. So again, here I have a less than or equal to. I do need to get my absolute value isolated first though. So before I start, I do need to subtract that 1 from both sides. So my problem becomes absolute value of 5x plus 1 is less than or equal to 9. Now I see absolute value less than a positive number, so I can split. So that 5x plus 1 repeats. The right side stays the same, and I mirror it on the left side. And now I work inner to outer. So I subtract 1 from all sides. 5x is less than or equal to 8 is less than or equal to -10. I divide by 5. We're dividing by a positive, so there's no need to change the direction of the signs here. And I have 8/5 on the right side and a -2 on the left. Now, 8/5 is the same as 1 and 3/5. So again, that just helps with graphing. So if I want to graph this, I'm going down to -2. I'm going up to 8/5. So, maybe like right here. I do have the equal sign, so I am going to use brackets on both pieces. And in interval notation, I'm going from -2 to 8/5. Again, brackets on both sides. Now, the last example like this is actually a little bit different. Notice that the absolute value is isolated, so that's important, but my right side is a negative. Now, we learned with equations that an absolute value is never going to be equal to a negative number, which is true. With inequalities, though, you have to think through it a little bit more because we're not saying it's equal to a negative, we're saying that it's less than a negative. So if we think about this here, the absolute value is either going to be 0 or positive, right? Absolute value cannot be negative. So the left side has to be 0 or positive. 0 or positive is never less than a -13, right? That's just never going to happen. Either the absolute value is 0, and 0 is not less than -13, or it's positive, and positive, any number is not less than -13. So for a less than symbol with a negative, we do also have a no solution here. So again, you can write that as the empty set. You can write it as the null set. If you were graphing this, you would pick the graph that has nothing on it. So for a less than symbol, again, this is not going to happen with a negative on the other side. All right, now there is a second case, and that's if you have greater thans, and actually something else happens. So a less than symbol is associated with a compound inequality that's an and. You have that sandwiching effect for those. For a greater than symbol, you actually have a compound inequality that's associated with an or problem. So they're very, very different. So you do really need to pay attention at the very beginning to see which way you're going to go. So you're going to rewrite and solve. Now, one version stays the same. The other one becomes a negative, but this time the sign on the left here does switch, right? It went from greater than to less than. So that is an important change to note here. All right, my absolute value is isolated. My other number is positive. I'm noticing a greater than sign. So one version is going to stay y. This is absolute value here, by the way. So it's not a 1 or anything. Y minus 3 is greater than 7. So that's the right side, stays exactly how it looks. You're going to put an or, and then you're going to do y minus 3, and notice that you're going to change to less than, and you're going to make it -7. And then you're going to solve each separately. So I'm going to add 3 to both sides. Y is less than -4, or y is greater than 10. So if I graph these, right, on the left side, I'd be looking at this. On the right side, I'm looking at this. Now remember, it's an or problem, so this is actually fine, right? With or problems, I'm not looking for the intersection, I'm looking for a union. So I'm just, anything shaded counts as an answer. I'm putting all the solution sets together. And again, if you're having trouble with this, we covered this with compound inequalities. So you want to go back and review that. And then that will remind you how to solve here. So our final answer really is that y is less than -4 or y is greater than 10. So either of those answers would make this true. And our graph would look like this. So it'd have shading on both sides. For interval notation, on the left side, you go from -infinity to -4. On the right side, you're going from 10 to positive infinity. And we would just put a little u in between those two pieces there if we wanted to write it in interval notation in that case. Next one, same sort of process. I do have to isolate that absolute value first here. I'm going to subtract 5 from both sides. So my absolute value is isolated, but I do see the right side as a negative. And again, negatives get really weird with absolute values. So think about what's going on here. My absolute value is either going to be 0 or it's positive. Now, if it's 0, well, 0 is definitely greater than -2, so that's fine. And if it's any positive number, it is also greater than -2. So no matter what the answer is for the absolute value, it will always be bigger than -2. So in this case, our solution is actually all real numbers, or negative infinity to infinity there. If you were graphing it, then you would color in the entire line. So for absolute values, most of the time, if the right side is a negative, for equations, it's always no solution. For less than, it's no solution. But for a greater than symbol here, again, assuming that the absolute value is greater than the negative, so my absolute value is on the left, then this actually is always true, right? No matter what this is, it's always going to be bigger than -2. So this is all real numbers. So watch out for those negatives. They do get a little tricky with absolute values. All right, let's do one more here. Again, I'm going to start by adding 7 to both sides. So don't make any decisions until you've isolated your absolute value. And once I isolate it, I see that my right side is now positive. So it's going to work as it should. Got my 1 there. There we go. So one side is going to be x over 3 minus 1 is greater than or equal to 2. The other side is going to be x over 3 minus 1. And then in this case, we're going to switch that to a less than or equal to, just mimicking, but reversing the symbol, and then a -2 instead. All right, I'm going to solve each of these separately. I do want to get rid of those fractions. I don't particularly like working with fractions. So I'm going to multiply both sides by 3. And don't forget on the left side, you do have to distribute. So you end up with a 3 times x over 3 minus 3 times 1. And I'm just going to kind of do them both at the same time here because at least the first step is the same. Here my 3's cancel. So I have x minus 3 is less than or equal to -6. Over here I have x minus 3 is greater than or equal to +6. And then now in each case, I'm going to go ahead and add 3. So I have x is less than or equal to -3. And x is greater than or equal to 9. Now, I didn't write it in up here, although I should have. These are OR problems, right? So when we're going in this direction, this is an OR example here. So if I were to graph this, on the left side, I'm going less than -3. And on the right side, I'm going bigger than 9. Again, because it's an OR problem, it doesn't matter that they don't overlap. My answer is anything shaded. So these two parts are my answers. If my value is bigger or 9 or bigger, or if it's -3 or smaller, if I were to plug it into the original problem way up here, I would get solutions that work. And if you're not sure, try it out. If I plug in, let's just do 9, right? 9 over 3 is 3. 3 minus 1 is 2. The absolute value of 2 is 2, and 2 minus 7 is -5, which is greater than or equal to -5, right? It checks out. So you can always plug in anything that's shaded and make sure that it actually works. For interval notation, the left side goes from -infinity to -3 with a bracket. The right side goes from 9 to +infinity, and don't forget we put a little u in between, again, to let the reader know that we're combining these two pieces, so both parts are part of our solution set.